Sometimes every now and then you get an easy one. No board that's been pissed on, no board that's been stepped on, no board that's had connectors ripped off and destroyed by other people. And today is one of those days. I mean, I was looking for MOSFET issues on this board. I was looking for shorts to ground everywhere. I was trying different DC in boards, different chargers, and then I noticed, what about the DC in fuse? So if you look over here, you'll see what I'm talking about. I'll just open up the schematic and show you. So when I click over here, AC adapter in goes to the DC in fuse, and that goes to the rest of the machine. And just because of my luck, I mean, it never occurred to me that the DC in fuse could actually be it, that I could actually have an easy life for a change instead of this complete nightmare of crap that you see on a regular basis. But the DC in fuse on this computer is bad. If I plug this in, I don't get a light. See? No light. Nothing. And one thing that you should know is that a charger, if it does not see a load, it will be limited in what it puts out. So let's take a look here. So on the side of the fuse that works, when I take this and put it in voltage mode, I'm going to measure voltage in the fuse right now, and you'll notice this is where this gets tricky if you're not used to working on this stuff. See, voltage is 3.38. It lowers the voltage when it doesn't see a load. And it doesn't see a load because the fuse is blown. So I mean, I'm not used to this. There's a board repair that is simple. I mean, how often does this ever occur? So, go over here. I can't believe this. Like, I'm going to solder a fuse and be done. Okay. Make it easy to remove. Lower the air on my hot air station. So I don't burn the plastic while removing the fuse. Getting really close on the fuse, so that melts first. Bam. And now we put a wire. Just kidding. If you want to know how this blew, 99% chance that it blew because of a knockoff charger. I might as well measure for a short to ground. I've been saying all this stuff about how this is an easy board repair, and yep, it is. Over 67 kilo ohms to ground. Yep. I mean, I said all that stuff about how I thought this would be the one board repair that's actually easy. And usually just because I said that, it would wind up having a short to ground inside the board where I had to run 16 fucking wires or something, but nope. All I really cared about there was getting it flat on the board. I can make it look neat afterwards with the magic of solder and flux. Okay, flatten the board. Turn off all the noisy stuff here. Back in the drawer you go. So much for easy board repair. Okay, let's see what else could be going on here. Yeah, about this being easy. Okay. Voltage goes up, voltage goes down. Voltage goes up, voltage goes down. Maybe we do have a greater problem. Ah. Boo. Alright. So, R6920. R6920, that's where that's going to go through to power PP3V42. Man. Of course it couldn't be just a fuse. Of fucking course it couldn't be just a fuse. Let's see, the resistance of R6920. What do I get? That's 47 ohms. That's what it's supposed to be from memory. Oh. Boo. Okay, let's think about this here. Let's be logical about this. What else could have gone bad? What's right after this fuse? R7020. Let's check. R7020. R7020. Oh, that's a current sensing resistor. Ain't nothing going bad over there. So what's right after that? So we have this MOSFET over here. We have this diode over here, which goes to R7005. So let's measure some of those things. Let's see. Where's D7005? I want to see R7005. I want to see Q7080. Oh, man, I really thought I was getting an easy one. Bullshit. Okay. Let's check. There was a student here today, and we were just going over this. It's like, well, why don't I get these problems? You know, 3.42 volts on one part of the board and not on the other. My board, dead SMC. His board, bad charging MOSFET. My board, charger power shorted to ground inside the board. I want easy ones. It's not fair. All right, so I'm getting 13, 20 ohms here. The schematic says 20 ohms. Well, the charging MOSFET is also right after it, so let's guess. Let's be logical and hope that being logical rewards us. Charging MOSFET is right after it in line, so if something happened to blow the fuse, perhaps MOSFET could also be bad. No such thing as an easy board repair. There is no such thing as an easy board repair. That didn't come off very nicely, which I'm happy about. That could actually, maybe it didn't come off nicely because it was dead, broken, and sticking to the pads because it was dead and broken. I can only hope. I can only hope. The fuse was definitely blown, though. 2.7 kiloohms on a fuse is not a reading that you want. So now we harvest from the donor board. We shove it onto this one. I can neaten up the solder later. Right now I want to see if I have any change. Hey, a light! Check it out! You can barely see that with the lighting in my office. Nah. Ooh. Let's not get spoiled now. Do we get a fan spin? If we get a fan spin, that would be sick. Yep. Fan spin. All right, now let's go over what was going on here in the schematic. This fuse was blown. So what I decided to do after I replaced the fuse, when it didn't work, rather than test a bunch of random stuff, was, you know, like how do you, because people will ask, how do you test this chip? How would you test this thing? And the way I often test it is looking at it, replacing it. You can do diode mode measurements to ground in every pin in an Excel spreadsheet, but let's face it, that's a huge waste of time. So right after F6905, that is PP18V5 DC in con, right? PP18V5 DC in con, which is also known as PPDCN underscore G3 hot. So I like to think of this like lightning striking. So after lightning strikes one point, what I like to do is figure out where else did the lightning strike. And this is from adapter, so I can only imagine that this is coming from the adapter after the fuse, PPDCN S5 charger. Let's see what that's a subrel of in the list. Yeah, so PP18V5 DC in con, PPDCN G3 hot, PPDCN S5 charger. So they're all the same thing up here. I just want to show you how you can find this, because I know I never explained how it is I knew that this automatically jumped to that. You can find it because over here it says this equals this, and this equals that. So after the fuse, there was an issue. The fuse is this power rail over here, PP18V5 DC in con. After that, I looked for whatever the next thing in line was, and it's this. After this is this. So I said, fuck it, let's replace this, and works. See? Not rocket science, you know, following lines and dots and arrows makes it a lot easier.